Hello. Okay, so I'm going to go over the quiz that we had in class. It's a collisions problem with momentum. I asked a couple people and I said, do you want me to do this in class? Do you want me to do this video? And I think most people were at first on the side of doing it in class because they'd pay more attention. But I'm going to do it as a video instead. One, it won't waste class time. Two, you can rewatch it, you can pause it, you can do whatever. So I think maybe you won't watch this, but you should. Let's get to work. Okay, so here's the problem. It says an object hits another object and it's deflected. Okay, so here we have the initial object's like this. It's 2 kilograms. It's going at 5 meters per second. Let's say it's that way. And then it says it's deflected through an angle of 60 degrees and has a speed of 3 meters per second. So this is before, and this is after. It's going like that. That's 60 degrees, and this is 3 meters per second. And it says, what's the momentum of the target? So here's a target. So if this comes in like that and collides, and it gets deflected down, the target's going to have to get deflected up. So let's call this object P and T. P and T. And we want to find this momentum PT2. Okay, so if we're dealing with an isolated system such that there's no external forces, in that case the change momentum is 0, or P before P1 equals P after. So I could write that as P1x equals P2x. Let's just start with that. Okay, so I know that there's 2 objects afterwards. So let's write down the x momentum equation. P, we have P projectile, and the x direction is just going to be the mass, 2 times 5. And then afterwards, we know the x momentum of this one. It's going to be 3 times 2 times 3 times the cosine of 60. Because this is the velocity, but we only want the x velocity, which is that right there. So here we have a right triangle, and the x component of velocity is 3 cosine 60. Now we have the x component of the target, and I don't know what that is, so let's put PTX. But look right there, I can solve for PTX. So PTX is going to be 10 kilogram meters per second minus 6 cosine 60, which is going to be cosine, that's 60. No, it's not half. Okay. And that's in kilogram meters per second. And let me just put this in my calculator, because if I make a mistake and it's on a video, you'll make fun of me later, and I don't like to be made fun of. So 10. That's 7. Okay, what's that? Okay, so that's 7 kilogram meters per second. 60. Cosine 60. Cosine 30. Okay, let's just figure that out later. Okay, so that's that. So now I have the x component of the, this is P target x. Now let's do the same thing in the y direction. In the y direction, the initial momentum is 0, and the final momentum is going to be PTY minus 2 times 3 times sine of 30. So PTY is going to be 2 times 3 times sine of 30. And I put that in my calculator. Did I say sine of 30? It's sine of 60. I'm sorry. I get 5.2. So the question said, what's the momentum of the target afterwards? I'm done. P target equals the x component, 7 kilogram meters per second x hat plus 5.2 kilogram meters per second y hat. That's it. Okay? And I just realized that the question I asked afterwards was, is kinetic energy conserved? Now, you can't easily do that. You can't. Because you don't know the mass. We didn't find the mass of the target. And in here, I just found the final momentum. So you can't do the problem, because you need the mass. Now, I did see a lot of people say, oh, well, kinetic energy is conserved because I could do this. K1, let's call that the projectile, big 4, plus K target before equals K projectile after plus K target after. And I know all three of those, so I could solve for the target. But that assumes that kinetic energy is conserved. And you don't really know that. What you would have to do is calculate the kinetic energy before and see if it's equal to the kinetic energy afterwards. In most cases like this, it would not be conserved. But it could be. But the most important part is a conservation momentum. So we said because there's no force, net force on the system of the projectile and the target, the initial momentum is equal to the final momentum, and then I just did that in the x direction and the y direction to find the x component of the target's momentum and the y component of the target's momentum. Put that together, and there you have it. What if I want to find the magnitude of the momentum afterwards? Well, I would just go pt magnitude square root ptx squared plus pty squared. That's the magnitude. You can't do this problem without using vectors. Momentum is a vector. And if you treat it as not a vector, that just doesn't work.